Imagine you are sitting on your porch on a quiet Friday evening in April 2029. The sky is clear, and as you look up, you notice a point of light that shouldn't be there. It's moving. It's not a plane, and it's not a satellite. It is a rock the size of the Empire State Building, glowing with a ghostly light as it screams across the atmosphere, closer to Earth than the very satellites that provide your television and internet. This isn't a Hollywood movie plot. This is a real event that NASA has marked on its calendar. The asteroid is called Apophis, named after the ancient Egyptian spirit of chaos, and for a long time it was the most feared object in our solar system. While the immediate panic has subsided thanks to better data, NASA is still watching this giant very closely. Why? Because Apophis is just the tip of the iceberg in a cosmic game of billiards where the stakes are the future of our civilization. We are going to dive deep into the world of near-Earth objects, the terrifying physics of a kinetic impact, and the secret planetary defense systems that are being tested right now to make sure we don't go the way of the dinosaurs. To understand why NASA is so focused on Apophis, we first have to talk about the scale of the threat. Space is mostly empty, but it is also filled with the leftovers of the solar system's creation. Most of these rocks stay in the asteroid belt between Mars and Jupiter, but every now and then, a gravitational nudge from a planet or a collision sends one of them tumbling toward the inner solar system. We call these near-Earth objects, or NEOs. Apophis is a big one, roughly 340 meters across. If a rock that size were to hit the Earth, it wouldn't cause a global extinction, but it would be a bad day for an entire continent. We are talking about an explosion equivalent to hundreds of nuclear weapons going off at once. It would create a crater miles wide and send a shockwave that would level cities for hundreds of miles. If it hit the ocean, it would trigger tsunamis that could swallow coastlines across entire basins. This is why, when Apophis was first discovered in 2004, it spiked the scales of the Torino Impact Hazard Scale like nothing before it. The initial calculations suggested a 2.7% chance of impact in 2029. In the world of orbital mechanics, 2.7% is a terrifyingly high number. It was enough to send NASA's Jet Propulsion Laboratory into overdrive. For years, every time Apophis made a distant pass, astronomers used radar and telescopes to refine its path. The goal was to find the keyhole. A keyhole is a tiny region in space, only a few hundred meters wide, where Earth's gravity would nudge the asteroid's orbit just enough to guarantee an impact on a future pass. If Apophis missed the Earth in 2029 but went through that keyhole, it was curtains for 2036. Fortunately, the latest radar data has ruled out an impact for at least the next 100 years. But that doesn't mean NASA has stopped watching. In fact, they are more interested in Apophis now than ever before. On April 13, 2029, Apophis will pass within 32,000 kilometers of Earth. That is inside the orbit of our geostationary satellites. It is very rare for an asteroid of this size to come this close. For scientists, this is the opportunity of a lifetime. It's a free laboratory. As the asteroid flies by, Earth's gravity will actually stretch and squeeze the rock, potentially causing asteroid quakes and shifting the dust on its surface. NASA is so excited about this that they have redirected a spacecraft called OSIRIS-APEX to meet Apophis right as it makes its close approach. They want to see how a planet's gravity affects a rogue asteroid. This isn't just for science, it's for defense. If we know exactly how these rocks are held together, whether they are solid chunks of iron or loose rubble piles of gravel, we know how to push them away if one ever takes aim at us. This brings us to the secret world of planetary defense. For a long time, people thought the only way to stop an asteroid was to blow it up like in the movies. But NASA knows that blowing up an asteroid is a terrible idea. Instead of one big rock, you now have 1,000 smaller, radioactive rocks heading toward you. It's like turning a cannonball into a shotgun blast. The real strategy is much more elegant. It's about the kinetic impactor, or the gravity tractor. NASA recently proved this works with the DART mission. They slammed a spacecraft into a smaller asteroid called Dimorphos, and it worked perfectly. They shifted its orbit. This was a historic moment for humanity. For the first time, we showed that we are not helpless victims of the cosmos. We have the technology to change the path of a celestial body, but DART was just the beginning. The biggest challenge in planetary defense isn't the hitting part. It's the finding part. Space is vast and dark. An asteroid like Apophis is as black as coal. Finding a dark rock against the blackness of space is like trying to find a charcoal briquette in a dark warehouse with a tiny flashlight. This is why NASA is building the NEO Surveyor. This is a space telescope designed specifically to find the hidden asteroids. It will sit at a stable point in space and use infrared sensors to spot the heat signatures of asteroids that are invisible to normal telescopes. The goal is to find 90% of all asteroids larger than 140 meters. Why 140 meters? Because that is the size where an impact becomes a major regional disaster. If we find them 20 years before they hit, we can nudge them with just a tiny bit of force. A 1-inch push today becomes a million-mile miss 20 years from now. For those interested in the space economy and finance, this is an area of massive growth. Planetary defense is becoming a specialized sector. Governments are realizing that the cost of a defense mission is pennies compared to the cost of an impact. But there is another side to this. The same technology we use to track and land on asteroids for defense is the exact same technology we need for asteroid mining. Companies are looking at asteroids like Apophis and seeing flying gold mines. A single metal-rich asteroid can contain more platinum, gold, and rare earth metals than has ever been mined in human history. NASA's interest in these rocks is providing the fundamental data that future private mining companies will use. We are seeing the birth of a trillion-dollar industry where the hazards of today become the resources of tomorrow. Let's talk about the city-killer asteroids. These are smaller, around 50 meters wide. They are much harder to find but much more common. In 2013, an asteroid only 20 meters wide exploded over the city of Chelyabinsk in Russia. It didn't even reach the ground. It exploded in the air with the force of 30 Hiroshima bombs. The shockwave blew out windows across the city, injuring over 1,000 people. No one saw it coming because it came from the direction of the sun, where our telescopes are blinded. This is why NASA is so focused on detecting these smaller objects. We want to avoid surprises. A 50-meter asteroid hitting a city like London or New York would be a catastrophe beyond anything we have modern experience with. NASA's Eyes on Asteroids program is a real-time dashboard that tracks every known object, giving us a digital border wall for the planet. Why is the composition of the asteroid so important? If you hit a solid rock with a spacecraft, it reacts predictably, but many asteroids are rubble piles. These are just collections of rocks held together by very weak gravity. If you try to push a rubble pile, your spacecraft might just sink into it like a spoon into a bowl of cornflakes. This is what happened with the OSIRIS-REx mission when it touched the asteroid Bennu. The surface was so soft it almost swallowed the probe. NASA is watching Apophis to see if it's a rubble pile. If Earth's gravity causes it to crumble or shift in 2029, we will know that we need a different kind of defense strategy for that type of object. Maybe instead of a kinetic impactor, we would use a gravity tractor. A gravity tractor is a heavy spacecraft that just flies alongside the asteroid. The tiny gravitational pull of the spacecraft is enough to slowly pull the asteroid off its course. It takes years, but it's very precise. Now imagine the logistics of a defense mission. You have to launch a rocket, travel through deep space for months or years, and hit a moving target that is traveling at 20 times the speed of a bullet. The math has to be perfect. 1 decimal point error and you miss, and the world is in trouble. This is why NASA's Deep Space Network is so critical. These giant radio dishes around the world are the only way we can communicate with our probes and track asteroids with radar precision. When NASA says they are watching an asteroid, they mean they are bouncing radio waves off it and measuring the time it takes for the signal to return to within a billionth of a second. This is how we know the orbit of Apophis so accurately that we can rule out an impact for a century. But what about the ones we don't know? This is the part that keeps space enthusiasts up at night. There is a whole class of asteroids called long-period comets that come from the outer edges of the solar system. They move much faster than asteroids and give us very little warning, sometimes only months. While NASA's current focus is on the local asteroids, they are constantly improving their long-range detection. The Vera C. Rubin Observatory, which is coming online soon, will take a massive picture of the entire sky every few nights. It is expected to discover millions of new objects. This will be a game changer. It will turn our patchy map of the solar system into a high-definition video. We will finally see the movements of the cosmic clockwork in real time. For the listeners who love the what-if scenarios, let's look at the financial impact of a near miss. Even if an asteroid doesn't hit, the mere threat of an impact can cause global chaos. Imagine if NASA announced there was a 10% chance of an impact in a specific region 5 years from now. Property values would collapse, insurance companies would go bankrupt, people would migrate in the millions. The economic damage from the panic alone would be staggering. This is why NASA is very careful with how they communicate their data. They have a specific protocol for announcing threats to avoid unnecessary alarm. They work with the International Asteroid Warning Network to make sure the data is verified by multiple sources before it goes public. Planetary defense is as much about managing human psychology as it is about managing orbital mechanics. Let's rethink the 2029 pass. When Apophis flies by, it will be visible to the naked eye for billions of people in Europe, Africa, and parts of Asia. It will look like a star moving across the sky. This will be a massive moment for global awareness. For the first time, people will see the reality of the threat and the beauty of the solar system at the same time. NASA plans to use this event to educate the public about space. They are planning citizen science projects, where people can help track the asteroid's brightness. This is about building a planetary culture. We are all on this spaceship together, and the more eyes we have on the sky, the safer we all are. Thinking about the future, NASA is already looking beyond 2029. They are thinking about active deflection tests. What if we launch a mission to an asteroid that isn't a threat, just to practice moving it? We could try different methods, like using lasers to vaporize part of the surface, creating a jet of gas that pushes the rock in the opposite direction, or using a nuclear standoff blast, where a device is detonated near the asteroid to heat one side and push it. These are the tools of a mature spacefaring civilization. We are moving from being passive observers of the universe to being active participants. The asteroid Apophis also tells us a story about the history of our solar system. These rocks are time capsules. They contain the original materials from when the sun was born. By studying Apophis, NASA is learning about the water delivery theory. Some scientists believe that Earth's oceans were brought here by asteroid and comet impacts billions of years ago. So, the very objects that we fear today might be the reason we exist in the first place. It's a poetic cycle of creation and potential destruction. NASA's OSIRIS APEX mission will look for organic molecules and water-bearing minerals on Apophis, helping us understand if these rocks are the seeds of life. Now let's talk about the billionaire space race and how it fits in. Companies like Blue Origin and SpaceX have the heavy lift rockets we would need to send a massive defense mission. If we needed to launch 10 DART-style interceptors in a row to stop a huge rock, we would need the launch frequency that only private companies can provide. This is a perfect example of a public-private partnership. NASA provides the science and the navigation, while the private sector provides the muscles or the heavy lifting. This collaboration is what makes a successful planetary defense system possible. It's not just one agency. It's an entire planet's industrial base working together. There is also the Yarkovsky effect. This is a subtle force that can change an asteroid's path over time. When an asteroid rotates, one side is heated by the sun and the other side cools down as it turns away. The heat radiating off the dark side acts like a tiny thruster. Over decades, this can push an asteroid thousands of miles off its predicted path. This is why NASA has to keep watching. You can't just calculate an orbit once and be done. You have to account for the sun's heat, the gravitational pull of other planets, and even the thermal recoil of the rock itself. It's a never-ending job of celestial accounting. For the space enthusiasts in the audience, consider the nuclear standoff option. While treaties ban weapons in space, many scientists agree that for a very large asteroid, discovered with short notice, a nuclear device might be our only hope. The goal wouldn't be to blow it up, but to use the X-rays from the blast to vaporize the surface of the rock. This creates a propulsion effect. It's a controversial topic, but it shows the seriousness of the situation. NASA participates in planetary defense tabletop exercises where they simulate these scenarios with FEMA, the Pentagon, and international partners. They play through the political and social consequences of having to use such an extreme measure. It's about being ready for the unthinkable. As we look toward the year 2026, we are entering a new era of neo-discovery. The James Webb Space Telescope is occasionally used to look at asteroids, providing incredibly detailed data on their minerals. The more we know about what they are made of, the better we can predict their behavior. NASA's Center for Near-Earth Object Studies is the brain of this operation. They process millions of observations from around the world every day. If you want to see what they are seeing, You can go to their website and see the close approach list. It's a reminder that we are constantly being buzzed by rocks. Most are small and harmless, but the list is a testament to how busy our neighborhood is. What happened to the asteroid that took out the dinosaurs? That was a 10-kilometer monster. An object that size is very easy to spot, and NASA is confident that there are no 10-kilometer rocks heading our way for the foreseeable future. The real danger is the middle class of asteroids like Apophis. They are hard to find, but big enough to ruin your century. This is why NASA is so focused on them. We have already found the big ones. Now we are hunting the stealth ones. This is the ultimate insurance policy for the human race. In the end, NASA's obsession with Apophis and other asteroids is a sign of our progress. Today we look at them with mathematics and physics. We have gone from being afraid of the dark to being the ones who map the dark. The pass in 2029 will be a celebration of that knowledge. It will be a moment when the world stops for a few hours and looks up, realizing that we are part of a grand, sometimes dangerous, but always beautiful cosmic dance. So, when you hear about NASA watching an asteroid, don't panic, be glad. It means we have our eyes open. It means the brightest minds on the planet are working to ensure that our story continues. Apophis is no longer a spirit of chaos, it is a teacher. It's teaching us how to survive, how to explore, and how to protect this pale blue dot we call home. The sky is not falling. We are just finally learning how to read it. Stay curious, keep looking up, and trust the science. We are the first generation in the history of life on Earth that has the power to prevent its own extinction from space. That is a responsibility NASA takes very seriously, and it's why they will never stop watching. The story of Apophis is a reminder that we live in a dynamic universe. It's not a static museum. It's a swirling, changing environment. Our ability to adapt to that environment is what defines us as a species. By tracking these asteroids, we are taking the first steps toward becoming a truly multiplanetary civilization. We are learning to manage our neighborhood. And as we do, we find that the things that once terrified us are the very things that will drive our progress. The 2029 flyby will be a landmark in human history, the day the world realized that space is not just up there, but right here, and we are ready for it. Keep an eye on the news as we get closer to 2029. There will be more missions, more data, and more excitement. NASA is already planning how to share the live images with the world. It will be the biggest live event in the history of astronomy. And through it all, the telescopes will keep turning, the radars will keep pinging, and the scientists will keep calculating. Because in the vast, silent reaches of space, there is always another rock, and we want to be the ones to see it first. Our future depends on it. And NASA is on the watch.